Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to design LC ladder type of low pass filter using open circuited stubs. In my previous video, I already explained LC ladder type of low pass filter at 1 GHz operating frequency. So now here LC ladder type of low pass filter using open circuited stub at 1 GHz operating frequency. So the previous design, that is stepped impedance low pass filter, realizes the shunt capacitors of the low pass prototype as low impedance lines in the transmission path. An alternative realization of a shunt capacitor is to use an open circuited stub, and its expression is omega c is equal to 1 by z naught tan of 2 pi by lambda g into L. So for length L is less than the half of the guide wavelength, and Z naught is the characteristic impedance. That characteristic impedance Z naught is 50 ohm transmission line. So now we are also in this design, so using open circuited stub, also the same high impedance transmission line. So that high impedance transmission line is 93 ohms are used for the series inductors, while the open circuited stub will have the same low impedance transmission line. So that low impedance transmission line is characteristic impedance is 24 ohms. Thus, the design parameters of the microstrip transmission lines already explained in my previous video, that is stepped impedance low pass filter at 1 GHz operating frequency. And this is the layout structure of the 3-pole microstrip low pass filter using open circuited stub on a substrate with a relative dielectric constant of 10.2 and thickness of the substrate is 1.27 mm. And this is the second waveform is the full wave electromagnetic simulator performance. So now here in this layout structure, uh, both the ends of the 50 ohm transmission line. So now here the operating frequency is 1 GHz and epsilon r is 10.2, and type of the material is roses RT or Duride 6010, and its relative permittivity is 10.2, and height or thickness of the substrate is 1.27 mm. So using microstrip online calculator, calculate the width of the 50 ohm transmission line. So the width of the 50 ohm transmission line is 1.1 mm, and the length of the 50 ohm transmission line is, I am considering 10 mm, and this is high impedance transmission line, and this is also high impedance transmission line, this is low impedance transmission line. So now where the length is 11.04 mm, and this length is 11.04 mm, and this length is 4.0 mm. Adding all these values, that are 10 mm plus 10 mm plus 11.04 mm plus 11.04 mm plus 4.0 mm. So adding all the values, the length of the transmission line is 46.08 mm. So here I am considering the length of the substrate is 46.08 mm and the width of the substrate is 36 mm. So now I am going to the HFSS software. So this is the previous design. So now here the substrate length and exercise is here 46.08 mm, 46.08 mm, and width of the substrate is 36 mm and height of the substrate is 1.27 mm, and x portion is half of the exercise value, that is 46.08 mm by 2 before representing negative sign, and y portion is half of the y size value and z portion is 0. So press OK button. And next change the dimensions of the ground plane, and this is the ground plane. So the dimensions of the ground plane is same as that of the dimensions of the substrate. Now the X size is 46.08 mm and Y size is 36 mm, and X position value is half of the X size value, that is 23.04 mm, and Y position is half of the Y size value, and Z position is, so that ground plane is below the substrate, so the height of the substrate is 1.27 mm. So below the substrate means that Z position is minus 1.27 mm. So press the OK button. And after that, on the top of the substrate, design 50 ohm transmission line, both the ends of the transmission line. So this is the 50 ohm transmission line. One end, change the dimensions. So the 50 ohm transmission line axis is Z axis, and length of the 50 ohm transmission line is 10 mm, and width of the 50 ohm transmission line is 1.1 mm, and position X position is 23.04 mm, and Y position is minus 1.1 by 2, Z position is 0. Press the OK button. And other end of the transmission line, and this is another end of the 50 ohm transmission line. So now the X position is minus 23.04 mm, that is another end, and high impedance transmission line. So in this layout, the high impedance transmission line length is 11.04 mm, and that high impedance is 93 ohms. So using microstrip online calculator, so high impedance transmission line, calculate the width of the high impedance transmission line. That width is 0.2 mm. So the width of the high impedance transmission line is 0.2 mm and length is 11.04 mm. 11.04. Next size is minus 11.04 and width is 0.2, and position and X position is 13.04 mm, and Y position is minus 0.2 by 2, Z position is 0. Press the OK button. And another end, and this is 13.04 and X size is 11.04. That is another end, and this is low impedance transmission line. So change the dimensions. So the low impedance transmission line, and height is 5.78 mm and width is 4.0. So and the X size is 4.0 and Y size is 5.78. So now we can change the dimensions, and this is 5.78 and X size is minus 4 and Y size is 5.78, and the position and X position is half of the X size value, 4 by 2 is 2, and Y position is 0.1 mm and Z position is 0. So now press the OK button. So this is the layout of the LC ladder type low pass filter using open circuited stub. So now change the ports, change the port dimensions, and the port 1 dimensions, and this exposition is 23.04 mm, and second port also this exposition value is minus 23.04 mm. So this is the structure of the layout of the LC ladder type low pass filter using open circuited stub. So now start the simulation. Check the validity. So design is successfully validated. Now start the simulation. So simulation is successfully completed. Next observe the return loss plot and insertion loss plot of the open circuited stub low pass filter. So this is the characteristics curve of the, and this red curve is the return loss plot, and this green color curve is the insertion loss or transmission curve.